For this lesson, we're going to take a look at factoring integers, and this is going to start our factoring unit in Algebra 1. First of all, the definition of a factor. Factors are numbers that multiply to give a certain value. So, for example, 4 and 6 are the factors of 24 because 4 times 6 gives you 24. So let's list all the factors of 24. Well, let's start with 1 and 24. That would be the smallest positive integer that can go into 24 is 1. Any number will always have factors of 1 in itself. But we also know since 24 is even, 2 goes into 24, so 2 times 12 will give us 24. And we also know that 3 goes into 24, so 3 times 8 would be 24, so 3 and 8 are factors of 24, and then 4 and 6. So these are all the factors of 24. Let's take a look at prime factorization and prime numbers. Prime numbers are numbers that have only 2 factors. So the number 1 itself is not prime. There has to be 2 factors, 1 in itself. So for example, 13 is prime because the only numbers that positive integers that multiply to give 13 are 1 and 13. Another example of a prime number would be 7 or 5. So what we're going to do here is find the prime factorization of a number, which means we're going to write the number as a product of primes. And the way I like to do this is to use what I call a factor tree. So we're going to figure out the first prime number, and here's a list of prime numbers: 2, 3, 5, 7, 11, 13, and so on. There's an infinite number of prime numbers. But we're going to figure out which of these prime numbers do we know for sure goes into 24, and since 24 is even, we know 2 goes into 24, and 24 divided by 2 is 12, so here's branches of our tree. But we can break 12 down even further. Since 12 is even, it can be thought of as 2 times 6, and we can break 6 down even further. It can be thought of as 2 times 3. So the prime factorization of 24 we could say is 2 times 2 times 2 times 3, or if we wanted to use exponents, we could say 2 to the 3rd power times 3. Let's take a look at this second example, writing 180 as a factor, as prime factors. Now, you might not recognize factors of certain numbers immediately, but here I think of 180 as being 10 times 18. Now, 10 and 18 are both even, so I know they're not prime. Those are both divisible by 2. So I can break down 10 into its factors of 2 and 5, and I can break 18 down into its factors of 2 and 9. Now 2 is prime, 5 is prime, 2 is prime, 9 is not prime. 9 can be thought of as the prime factors 3 times 3. So notice at the end of each branch, once we're done, at the end of each branch here we have a prime number. So the prime factorization of 180 can be thought of as 2 times 5 times 2 times 3 times 3, or if we put the 2's together, this would be 2 squared times, putting the 3's together, 3 squared times 5. That would be the prime factorization of 180. Well, where we're going to be working with factoring is factoring polynomials. And in order to factor polynomials, we need to be able to identify what's called the greatest common factor. The greatest common factor of 2 numbers is the largest factor common to the 2 numbers, or the largest factor that will go into both the numbers. So for example, here we've got 12 and 15. The greatest common factor would be 3, because we know 3 goes into 12 evenly and 3 goes into 15 evenly, and that's the largest number that goes into both 12 and 15. So what is the greatest common factor of 20 and 48? Well, let's list the factors of 20. We have 1 and 20. And we have 2 and 10, and we have 4 and 5. And let's list the factors of 48. We'd have 1 and 48, and 2 and 24, and 3 and 16, and 4 and 12, and 6 and 8. Well, which of these numbers is the greatest common factor to both of these? They both have a common factor of 1. They both have a common factor of 2. They both have a common factor of 4, and that's it. That's the largest common factor that goes into both of those. So the greatest common factor of both of these is 4. And one way to write greatest common factor is GCF. Okay. Another way to figure out the greatest common factor would be to write the prime factorization of each number. So with 20, we know that 20 can be thought of as 2 times 10, and that can be thought of as 2 times 5. So we have 2 times 2 times 5. And then 48, we know can be thought of as, we'll say 6 times 8. And this can be thought of as 2 times 3. And this could be thought of as 2 times 4. And that can be broken down further into 2 times 2. So the greatest common, or the prime factorization of 48 would be 2 times 2 times 2 times 2 times 3. So what factors do these have in common? Well, they have a 2 in common, and they have another 2 in common, but that's it. So notice what they have in common is 2 and a 2, or 2 times 2, which is 4. So that's another way you can identify the greatest common factor. Well, what about the greatest common factor of 4x squared and 8x? Well, let's write 4x squared as 2 times 2 times x, and let's write 8x as 2 times 2 times 2 times x. Well, what do these have in common? Well, a factor in common to both is 2 and another 2, and they also have an x in common. So that means that the greatest common factor, the largest number that is divisible into both 4x squared and 8x, is 2 times 2 times x, or 4x. Don't forget to do the survey at tinyurl to make sure you have some more practice with identifying factors, prime factorization, and greatest common factor.